Hi everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Okay, so welcome to my video. So basically this is a lecture video for subject Electrical Circuits 1, code BEV 10303. Okay, so my name is Dr. Nur Zulaili binti Muhammad. So this is my email address. So you can just feel free to email me whenever you have a question to ask me, okay? So in this video, we are going to learn on chapter 1 of this subject, which is basic concept of electrical circuits. Okay, so let's move to the next slide where we are going to see the content. The list of topics that we are going to cover for chapter 1. Okay, so first of all, we are going to have a look on the brief introduction to the electric circuit. So what does it mean by electric circuits? Okay, so what are the importance of learning on the electric circuit? Okay, so, and then after that we are going to see the concept of system of units, why we need the system of units. Okay, and then after that we are going to see the definition on electric charge and Coulomb's law. Alright, and then after that we are going to see the definition of current and voltage, definition of energy and power. Okay, and then after that we are going to see what is the difference between active and passive element. And then finally, we are going to see what is the definition on electrical sources and what is the difference between independent sources and dependent sources. Okay, but basically in this video, we are trying to cover maybe until subtopic 1.3 only. So for the next subtopic, we are going to cover it in the next following video. Okay, so let's move to the first subchapter, which is introduction to the electric circuit. Okay, so basically, okay, let's say you are given this kind of figure, which is it represents the basic electrical circuit. Okay, where you have a battery here, you have a lamp here, and you have a wire connected between battery and the lamp. Okay, so when you have a different potential of voltage here, so it will cause the current to flow from the battery to the lamp. So that's why when you have this kind of complete circuit, so the lamp will be turned on. Okay, all right. So electrical circuit is actually interconnection of the electrical elements. So in this case, your electrical elements is a battery, is a lamp, and is a connecting wire. Alright, so the function of the electric circuit is to transfer the energy from one point to another point. So in this case, you are transferring the energy from the battery to the lamp. Alright, and then based on the electrical circuit, there is a few basic concepts that you must know in order to understand the fundamental of the electrical circuit. So the concept includes the definition of charge, current, voltage, power, circuit element. So in this case, the elements represent by battery, lamp, and the connector wire. Alright, and then finally you are going to see the definition of energy. Okay. So now let's move to the second subchapter, which is system of units. Okay, so why do we need the SI system? Okay, so as an electrical engineer, we deal with measurable quantities. Okay, such as maybe you deal with voltage, you deal with current, you deal with whatsoever quantity lah. Alright, so however, our measurement must be communicated in the standard language so that it can be understood by all, regardless at which area or at which country does the measurement take place. Okay, so in order to consider the measurement can be understood by all, so that's why we need to come up with the international measurement language, which is SI system. Okay, so the SI system, or the other name is the International System of Units, can be divided into two classes. Alright, so the first one is a base unit, the second one is the derived unit. Right. So what does it mean by base unit and derived unit? So we go to the next slide. Okay, for the SI base unit, it basically represent the basic quantity of the units. Okay, so we have actually around 7 base unit, which is length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. So this is the name of the unit that we use. For length we use meter, for mass we use kilogram, for time we use second, and for electric current, we use ampere. For thermodynamic temperature, we use Kelvin. For amount of substance, we use mole. And for the luminous intensity, we use candela. Alright. So basically, this is the symbol that we use in our measurement. Okay. So next, for the derived unit. Okay. So how about the derived unit? So basically, the derived unit is coming from the base unit itself. So the derived quantities are formed by combining two or more of the fundamental quantities. So the fundamental quantities refer to the base unit lah. Alright. So example, maybe for area is length multiplied with width. So for length, we measure it in meter. So width also we measure in meter. So we combine the meter and meter, so we can come up with the area. Okay, so this is what does it mean by the derived unit. We derive it from the base unit. Alright, and then for the second one, example, maybe for volume is equal to length multiplied with width multiplied with height. Alright, for speed is equal to distance over time. Okay, for distance, maybe the measurement is in meter, and then time is in second. Okay, and then after that, density is equal to mass over volume, and the note here, you must know that most of the units in international system are derived units. That is, units that define in terms of base unit. Alright, so like this lah. Okay, so this is the derived unit. Alright. Okay, see. Okay, for the electrical quantity, this is the quantity that we always use in the electrical analysis. Okay, so we have charge, which is the symbol is Q, and then the unit is Coulomb, and then the charge is also a derived unit, which is current multiplied with time. Okay, for current is equal to I, and then the unit is ampere. Energy we have joule, power we have watt, voltage is volt, resistance we measure in ohm, conductance we measure in Siemens or mho, impedance we measure in ohm, reactance also we measure in ohm, and capacitance we measure in farad, inductance we measure in Henry, frequency we measure it in hertz, and magnetic flux we measure it in Weber. So this is the derivation that you might have a look at by yourself. Okay, so basically this is the basic electrical quantity that we must know, we must understand in order to do the electrical analysis. Alright. Okay, so now prefix in the SI units. Okay, so what does it means by the prefix? Okay, so basically this is the prefix. You have tera, giga, mega, kilo, milli, micro, nano, pico. Okay, so basically one of the great advantage of using the SI units is actually it use prefix, which the prefix is based on the power of 10. So you have example, you have 10 to the power of 12, so you can represent it by tera. Okay, so the use of this prefix is so that you can relate the larger and smaller unit to the basic unit. Okay, example, okay, let's say you have a 600,000 meter, so you can relate it to become 600 kilometer, or maybe you can represent it in 600 million millimeter. Okay, so you have a milli there, or you have a kilo there. So this is the usage of the prefix, where you can relate the larger and the smaller unit to the base unit. So this meter is a base unit. Alright, okay. So next, let's go to the next subchapter where we are going to see the concept of electrical charge and the concept of Coulomb's law. Alright, so first of all, we need to know the structure of an atom. Okay, as you might know that all things are made of the indivisible particles, we call it as an atom. So inside our body also we have an atom. So any material in the world are made by the atom. Okay, so each atom consists of electrons, protons, and neutrons. Okay, so basically this is the structure of an atom. Okay, so where you have a nucleus in the middle. Alright, and then you have the proton and neutrons as well, and then the electrons is the moving part at the axis. Okay, and then for protons will bring the positive charge, while the electron will bring the negative charge. Okay, right. So how about the electric charge? Okay, when we say electrical charge is actually electrical property of the atomic particles of which the matter consists. Okay, so usually for charge we symbol it as a Q. You can become a capital letter of Q or small letter of Q, and then we measure the electric charge in unit of Coulomb. Right, so 1 Coulomb is actually equal to quantity of the electricity conveyed in 1 second by a current of 1 ampere. Okay, so the definition is equal to Q is equal to I multiplied with T. Okay, so from this definition we come up with this expression. So 1 Coulomb 1 coulomb is equal to quantity of the electricity conveyed in 1 second by a current of 1 ampere. Okay, so 1 ampere multiplied by 1 second is equal to 1 coulomb. Okay, and then each atom consists of electrons, protons, and neutrons. So you know that the charge of electron is negative charge, while a proton carries a positive charge. Okay, so 1 electron charge is equal to negative 1.602 multiplied with 10 the power of negative 19 coulomb. And for the proton charge, it have a same magnitude but in a positive way, right? So basically, this is how the electron flow. Okay, so the electrons is flow from negative side to the positive sides. Okay, so it's actually vice versa from the current flow. Okay, because the current flow from positive to negative, but for the electron, it flow from the negative to the positive side. Okay. Okay, so how about Coulomb's law? So in the work of the static electricity, okay, you know that oppositely charged object will attract. So, and then object with like charges will repel. So it means that, okay, for a girl and boy, so we attract to each other, right? So negative and positive will attract, but girl and girl is, we can't attract to each other, so that's why we repel. Okay, so it means that unlike charges attract and like charges repel. So this is the basic this is the law that defined by Coulomb's. Okay, all right. So the Coulomb's law also said that, okay, let's say you have a charge, you have a positive charge here, you have a negative charge here. So there will be a force coming in between the charges where it will attract to each other, and then R is represent the distance between these two charge. Okay, so the size of the electrostatic force, okay, the size of the force F is proportional to the product of the magnitude of the charge. Okay, so F is equal to product of the positive Q multiplied with negative Q. Okay, and then the electrostatic force is inversely proportional to the square of the distance separating the charges. So meaning that the F is inversely proportional to the R squared. Okay, so in the mathematical, we know that the F, the electrostatic force, is equal to K multiplied with Q1 multiplied with Q2 over R squared. Okay, so this K is represented by the Coulomb's constant, which is the value is 8.99 multiplied with 10 over 9 nanometer squared, Coulomb's negative squared. All right. Okay. So that's all for now. So thank you for watching. I'll see you in the next video. Bye.